So, so I'm now going to deliver a new lecture on the magnetotelluric method for my lecture series 3. Here in this lecture, I'll be delivering about the magnetotelluric data response and the inversion modeling, the steps associated with the inversions, and simultaneously some case studies that will best describe the magnetotelluric results and along with its associated methods, just like transverse electric, transverse magnetic modes. And the case study will be given based on the pilot study uh, carried out by Geological Survey of India in the eastern and the western southern India, and also in the outside of India, I mean East Tennant region, northern Australia, Manuguru Geothermal field. So myself, Dr. Devajiri Shah, as Senior Geoscientific Officer, I'll be delivering the lecture for your preparation for Combined Geoscientist Examination. The basic aspects of magnetotelluric methods. So basically the data processing flowchart is obviously first to import the data, then you do visual correction. If there are any spikes in the time series data, you correct it manually. Then you check the cross coherency components, and you will have to carry out the robust marks, the time marks, the magnitude and the phase marks in the time domain or in the frequency domain regime. So this one is the first, that is one of the thing is the robust marks, which is the power suppression using the robust algorithm methods, coherence method. So time series you will trending and the retending, and you will carry out first Fourier analysis, then you can carry out the compute cross power spectrum transfer function, and then you will uh, arrive at the resistivity, that means xy yx component along with the phases. So the whole chart is prepared here, and at the last, if you are satisfied, you can export the EDI file. And for a specific frequency, you will have to plot the cross flowers on a vector diagram, that is called on a polar. So talking about the basics, this is the transverse electric and the magnetic mode, where the electric field is considered parallel, that is called to the strike, there is a transverse electric mode. When the magnetic field is parallel to the strike, that is called transverse magnetic mode. They can be, I mean, the responses of that two modes can be inverted by using the NLCG methods that is implemented in the Wingeling software package. And you can finally arrive at the subsurface resistivity modeling by jointly inverting the transverse electric and the transverse magnetic mode and using that in. There are some, so this is the, I mean, electric, the vector of the electric and magnetic field along with the impedance tensor E is equal to Z into omega in, along with the component in x, y, y, x, z, x, z, 9 components. So using that components of the Z, you can reach a method of skew method. You can take on that is called the diagonal elements, sum of the diagonal element divided by the subtraction of the of diagonal elements. So for 1D, I mean the 1D case, that z xx and yy is equal to 0. So skew, the dimensionality analysis is the 0. So for 1D, that skew is 0. And for 2D case, that diagonal element xx yy 0 per yx is not is equal to xy. So, and but for 1D case, that is xy is equal to minus of yx. So the metric, generally you can get the metric of on diagonal elements of 0 and with the off diagonal element. And finally, at the 3D case, which is in the practical, you can have the non-zero elements of off diagonal and the on diagonal elements. So you can have all the tensorial elements xx, y, yx, yy. So if this shift skews parameter tensor that is less than 0.3, that is called the subsurface conductivity structure, is predominantly a 2D structure. It is actually serving as a diagnostics tool for identifying the distortion in the 3D. We can arrive at the data analysis and the interpretation. Already I have told, that is the, you have a time series data, you can convert the time series data into frequency spacing data and calculate the spectra and the impedance tensor, and then you define the dimensionality and the geoelectric strike direction and the regularization trade-off curve for inversion parameters. Finally, you can give the, I mean, you do the pseudo section of the data, which will give you an impression of the resistivity variation with the depth and the distance. And that subsurface resistivity modeling is obviously by, you can, I mean, invert the T and TM mode for apparent resistivity and the inversion data. So basically, in a 1D or 2D inversion model that are fast or easy and almost, I mean, 1D mostly strong. Compared to that, 2D inversion model is more slower and difficult, and usually programs will be available. And finally, you have to reach the 3D modeling, which is used to verify the 2D results, seeing our heterogeneity in the earth. So data, I mean, for 3D modeling, the data should be acquired in the grid mode. 2D inversion modeling is a non-linear, non-unique, and unstable problem. You can have infinite set of models for one solution, and so regularization is required to find a better solution. You have to apply prior information, geological, geophysical, all the inputs. So now you can see the CO2 sections of using the pilot project study in the Dharwar and the Singbhum craton for the CO2 section data, which is a taken out from the pilot. So you can see from the case study example that at a higher frequency range, it is showing the period. So period is decreasing as, so frequency is increasing here at the higher frequency range. That means 100 hertz to 10 kilohertz. That is, I mean, the dimensionality indicator is 0. So it is 1D or 2D in, uh, but if we conversely see at the below 0.01 hertz, and the grid, that dimensionality indicator is more or less greater than is equal to zero point 0.3, which is indicating a transition from 1D or 2D to 3D structural characters from the pilot project study. That is the Z skew, the shift skew case for in a pseudo section in a profile. So TM mode is an efficient mode to, I mean, look by locating the subsurface resistivity structure, because T mode is more sensitive to the heterogeneity than. Now we can see there is also bahr skew is another method which can be adopted as a shift skew, because the shift skew techniques is highly sensitive in the near surface. There will be cultural noise, the complex geological structures, the galvanic effects, and due to which it may overestimate the 3D effects at the lower frequency. So to see the lower frequency data, the bahr skew method is effective. So you can see there is at higher frequency, same like shift skew, the majority of the stations, these are one of the stations where the magnetotelluric long period magnetotelluric data were acquired. There are mostly 1D or 2D structure, but 1 hertz to 10 to the power minus 3 hertz, that means a very low frequency. The stations have skew values greater than 0.3. So it is, the red color is indicating the higher values of shift skew. So it is showing the localized 3D effect. Now we can show you some examples of the magnetotelluric data for mineral exploration. That is audio magnetotelluric methods. There are total 131 stations you can see, and which is roughly 2 to 10 kilometer spacing. That is the East Tennant region, that is northern Australia. Here you can see another indicator of phase tensors, that is along the central. The colored phase tensor indicating the 3D effect. Now MT method is generally applied for, I mean, the geothermal cases in the geothermal studies that is carried out in Telangana state and Manuguru Geothermal field. There are 3 MT stations layout, that is P1, another is P2, another is P3. You can see 3 stations, and that is plotted on a elevation maps. And some P1 is plotting crossing through higher elevation points, some lower elevation. You can see that, and finally we obtain the resistivity, the depth, the pseudo section resistivity pseudo section. That red color is indicating more resistive. There are in a background of low resistive zone, there is a highly resistive zone, that R1, that R2, and there is a highly conductive zone is here. You can see that along the stations, the 2D inverted models along the profile P1, P2, and the P3. So you can see there notably there are a very low 4 ohm meter low resistivity highly conductive zone at a distance of 8 kilometer from that ground distance, the conductive zone that is obtained by inverting a resistivity section in a Manuguru geothermal field, highly geothermal heat province region or highly conductive region that can indicate. So now I will show you some vertical sections along the denser transects and the that same depth. So some depth slices are obtained at some distances, 2 kilometer, 5, 10, 20 kilometer, and that is called the 3D sections. In that scale, that some conductive zones C1, C2, C4, C5 in the background of, in the highly resistivity section in the background of low resistivity sections. From our Indian case study scenario, eastern and the west southern Dharwar and the craton. So you can see some period phase tensor analysis. So one by one, let me describe. So at frequency greater than 1 hertz or period less than 1 second, the station exhibit more the elliptical phase tensors in the red color that is consistent with depth, and the skew value shows the local structural complexity. For frequency is equal to 1 hertz, that becomes more prominent. The phase tensor appearing more elliptical in nature, and which is suggesting 3D conductivity effects at greater depth, and which is consistent with the bahr skew results. And whenever you can find the intermediate frequencies between the ranges, that means 10 to the power minus 1 to around 10 to the power 10 to the power 1 to 10 to the power 3 seconds, the elliptical orientations are generally more uniform. That means that a predominantly 2D subsurface structures conductivity, and that there is also rose plots. They are showing this regional strike direction, and which is overall a northwest southeast trending, and in the 0.1 to 0.001 hertz frequency band, a recurring northeast and the south southwest strike direction is observed, which is showing that we can have deeper conductivity structures that follow this orientation. So we have described all the phase tensor analysis and the rose diagram from the strike direction using all the bahr skew and the shift skew. uh, So you are having the recent advances there that is also have described in the previous methods, showing the magnetometrics for the regional mineral targeting. You can integrate the empty data with other regional data sets, and the researchers can identify conductive anomaly methods and have it inverted the empty 3D AMT survey for porphyry copper deposits. Now our main, I will show you the final results of the 2D inversion model that is in the eastern India. There are two profiles where the stations are connected, the medium, the broadband stations and the long period stations, two long period stations, and 1, 2, 3, 4, 5, total 12, 14 broadband stations. And along that profile one, along that stations one profile, and that depth versus distance, that's to the inversion modeling is obtained. Generally it will show in uh, mm, that the upper crust that is exhibiting from 0 to 10 kilometer higher resistivity, very high resistivity, that is shown by the blue, and it is consistent with the crystalline basement in P1 and P2 both the profile, and it is shown more prominent near surface conductive zone, this one, but where it is shown the deep conductive zones. And so the P2 shows the more resistive and the laterally uniform shallow crustal layers, that all the crustal layers, and more compact and less fluid, less upper crust in the eastern region. Now we can see the one of the sections in the Dharwar craton in the southern region, that is showing that conductive zone in the intermediate conductive zone along that profile, where the um, broadband magnetometric stations, and the yellow is the that is at the 5 kilometer distance, and the yellow is the long period magnetometric station that is at the 55-kilometer distance. So you can see that the conductive anomaly zone C1, uh, and which is which can be interpreted as a deep-seated expression of Chitradurga shear zone geologically, and which is a major tectonic region which is separating western and the eastern Dharwar craton. And there is a prominent higher resistivity zone in the background R1, around 8192 ohm meter, that can be correlated with the stable dry and the crystalline rocks. And you can see the load. So the low resistivity or the region, that is C1, at a depth of around 40 to 100 kilometer, that is due to the presence of hydrous minerals. That is how it is interpreted. That's 2D inversion model. So friends, I have described all the methods and how the data analysis and interpreted things in my lecture. So if you have any doubt, you can write in the comment box of this YouTube, and can contact me in case of any doubts. These results and the methods will be very useful for your upcoming geoscientist examination UPSC, in the written and also in the interview method. Namaskar.